So without retention, there is no separation, and without separation, there is no resolution. So retention becomes very important for way to quantify our compound, for way to understand and qualify our compound. So identification and quantification can only happen once you have the retention of the compound onto our stationary phase. But how this retention takes place onto the stationary phase? What are the different mechanisms because of which you can get the retention of your analyte? That is something going to be discussed as the very first point. I hope you will find this information truly helpful. You must have heard about something called as the RPLC, or reverse phase liquid chromatography. So what happens in the reverse phase chromatography or reverse phase liquid chromatography? Your stationary phase is what? Non-polar or polar in the nature. What is the nature of your stationary phase in case of the reverse phase liquid chromatography? Come on, if you know, please let me know in the comment box. What is going to be the nature of the stationary phase or the column? Ananta says it's going to be polar. Dharav says it's non-polar. Chetan says non-polar. Pradeep says polar. Okay. Kavya says non-polar. Ashutosh says polar. Non-polar, non-polar, polar. So understand, the reverse phase liquid chromatography is the mode of liquid chromatography wherein your stationary phase is slightly non-polar as compared to your mobile phase. What is the nature of stationary phase going to be? It is going to be a non-polar as compared to your mobile phase. So please type in NP for non-polar in the comment box. Type in NP for non-polar. That's the non-polar is the nature of our stationary phase when we talk about the reverse phase liquid chromatography. And we'll start our discussion on understanding how the retention takes place in the reverse phase liquid chromatography. So this is called as the hydrophobic interaction. Now, what is meant by hydrophobic interaction? This is the interaction with the hydrophobic compounds onto the hydrophobic stationary phase. Hydrophobic stationary phase is nothing but the non-polar stationary phase. So as our stationary phase is non-polar, what is going to be the like attracts like rule? The non-polar compound can have the better retention or better interaction onto our non-polar stationary phase. How many of you heard about like attracts like? Type in LAL for like attracts like in the comment box. This is a very fundamental rule. This is a very natural rule, and based on to that, you can understand the retention possible for the compound. So if our stationary phase is non-polar, the non-polar compound is going to have the longer retention time or the poor retention time. Type in L for longer or P for poor in the comment box. I'm talking about the reverse phase liquid chromatography, and I'm asking the question, what is going to be the retention possible for the non-polar compound? And we just understand about the like attracts like. As our stationary phase is non-polar, the non-polar compound is going to have the good amount of interaction, and that will result into the longer retention. That will result into the longer retention. So what makes the compound non-polar? Yes, what makes the compound non-polar? The compound may becomes more non-polar or hydrophobic because of the presence of the non-polar moieties like long carbon chains, as someone has rightly commented. So more are the alkyl carbon or hydrocarbons present into the compound, the more will be the non-polarity of the compound. Is it true or false? Let me know in the comment box. Is it true or false statement? More are the number of hydrocarbons. The compound is going to be more non-polar. Is it a true statement or the false statement? It is the true statement, isn't it? So addition of alkyl carbon increases the retention. Why? What is the reason behind this statement now? The addition of alkyl carbon increases the retention. Why so? Let us take an example, and I will share the structure onto screen now. Let us understand this now. Why the alkyl chain increases the retention of compound on reverse phase liquid chromatography? Increase in the interactions, like attracts like, right? Because our compound will become more non-polar, and more is the non-polarity, more will be the interaction, and that's how the compound will get retained for the longer time. Awesome. Let us now understand. These are the three compounds into your hand. So tell me in the comment box, which compound is going to have more retention time or longer retention time? Which compound is going to have the longer retention time? The first, second, or the third? Which one is going to have the longer retention time? Come on, type in 1 or 2 or 3. It is going to be 1. Okay, Tushar says 1. Someone, and majority of you are saying 3. Why 3? Because look at here, alkyl chain. Can you see the alkyl ethyl chain over here? Isn't it? The compound number 3 has the longer or more amount of alkyl chain. The hydrocarbon presence is more. Yes or no? Type in the comment box. Compound number 3 has a more number of hydrocarbons, isn't it? And hydrocarbons makes compound what? Come on. Hydrocarbon makes compound polar or non-polar? Type in the comment box. P for polar, NP for non-polar. More are the hydrocarbons, more is going to be the non-polarity of the compound. And if the compound becomes non-polar, our stationary phase is also non-polar or hydrophobic. And because of that, the interaction gets increased, and that particular compound will retain for the longer time. I hope you understand why the compound number 3 will get retained for the longer time. Type in U for understand in the comment box. Do you understand the logic behind the higher retention of the compound 3? Type in U in the comment box, isn't it? And which compound is going to have the poorest retention time possible amongst these 3 compounds? What is that compound going to be? Is it 1 or 2? Please type in the comment box. So compound number 1 has the least amount of hydrocarbon chains, and because of that, the compound will have the poor interactions and going to have the poor retention time. Easy to understand? Type in E for easy in the comment box. Are you talking about very hard science or easy science? Let me know in the comment box. E for easy in the comment box. Awesome. Thank you so much. It's easy, not tough. Similarly, addition of the polar groups like hydroxy, amine, amide, carbonyl. Now, this polar groups is going to decrease the non-polarity or increase the non-polarity. Type in the comment box. The polar functional groups decreases the non-polarity or increases the non-polarity. Listen carefully. The polar functional groups like hydroxy decreases the non-polarity or increases the non-polarity. They are decreases the non-polarity. They are decreases the non-polarity. So if the compounds has a decreased its polarity, what is going to be its retention time? Will the retention time decrease or will the retention time increase? Yeah, type in D or type in I for I increase in the comment box. You understand now? So in case if my compound has got some polar functional groups like hydroxyl, what is going to be the retention time? Increase or decrease? Yeah, please type in the comment box, increase or decrease. And let us have these 3 components as an example once again to understand this retention mechanism. So which compound according to you, is going to have the highest amount of retention time? Highest amount of retention time. Is compound 1, 2, or 3? I am talking about the reverse phase liquid chromatography. I am talking about the reverse phase liquid chromatography. So which compound is going to have the highest amount of retention time? Understand, the compound which does not have any polar functional groups like hydroxyl. And what is that compound? That is the compound number 2, isn't it? And on top of that, the compound number 1 does not have the methyl group. Compound number 3 has the methyl group, but there is again the reduction into the non-polarity because of this hydroxyl group. So between 2 and 3, which one is going to be more non-polar? Between compound 2 and 3, which compound is going to be more non-polar? Is it compound 2 or compound 3? It is not the 3. Understand, in compound 3, you have the additional hydroxyl group. And what is the nature of hydroxyl group? The nature of hydroxyl group is decreasing the non-polarity. So comparing the compound number 2, the compound number 3 is going to be less non-polar. And compound number 2 evolves as a highly non-polar compound. Isn't it, yes or no? And as the compound number 2 is the highly non-polar compound, it can expect to have the more retention time. Understand this point, type in U for understand in the comment box, that how compound number 2 is going to have the highest retention time. Awesome. Thank you so much. Let us now discuss about compound number 1 and 3. Let us now discuss about compound 1 and 3. So according to you, which compound is non-polar or more non-polar? Is it compound 1 or is it compound 3? Please type in the comment box quickly. Why compound number 3 is non-polar as compared to 1? What is the reason behind that? Why compound number 3 is non-polar as compared to compound 1? What is the difference between them? Absolutely. Vaishnavi, you have picked up right point. Thank you so much. The addition of alkyl methyl group, the addition of methyl group has increased the non-polarity of the compound 3, but the same methyl group is not present in the compound number 1. Hydroxyl groups are present across both of them. So that is not the differentiating factor. The differentiating factor is what? The differentiating factor is the addition of one methyl group in the compound number 3, and methyl group is the non-polar groups, and that's the reason compound number 3 is more non-polar as compared to compound number 1. How many of you are clear on this concept as well? Type in C for clear in the comment box. Have you understood why the compound number 3 is non-polar as compared to compound number 1? Yes or no? C for clear or CC for crystal clear? If for crystal clear. Then which compound is going to have the least retention time in RPLC? Which compound is going to have the least retention time in the RPLC mode? 1 or 3? Yeah. Dharav says 1. Pallavi says 3. Ujjwala says 1. Neeraj says Trupti 1. Abhay 1. Neeraj 3. Okay. Someone more. 1, 1, 1. Okay. Srinivasan 3. Awesome. Please understand the most polar compound is going to have the least retention time in the RPLC. Yes or no? The more polar compound is going to have the least retention time. As we concluded that the compound number 1 is the least non-polar or the highly polar, then the compound 1 should be least retenting compound, no? Yes or no? Prasun, how come 3? How come 3 is going to be the least retenting compound? Compound number 1 is the more polar, isn't it? And because of that, compound number 1 will have the least retention time. John Stock, awesome. Thank you so much. You understand this point now? Please type in U for understand in the comment box. We are just beginning and getting warmed up, but I'm so excited and I'm so glad to have such an interactive audience today. Awesome. Thank you so much. Pleasure. Let us now understand the second type of chromatography, and it is the normal phase liquid chromatography. Ready for the NPLC retention behavior? Type in R for ready in the comment box. Again, we are going to learn from the theory and with the help of some practical examples. How many of you like this concept of learning? Please type in me with lots of ease in the comment box. I don't just talk about theory, I also talk about the practicals, so that the people can easily grab the information and you will be able to implement these learnings into your practical areas. Is it implementable? Type in yes or no in the comment box. Can you use this information into a practical work? Yes or no? Yes or no? 100%. Yeah. How many of you say yes or no? Awesome. Thank you so much. Let us now understand the normal phase liquid chromatography. So what is the reverse? What is the stationary phase in the normal phase liquid chromatography as compared to a mobile phase? Is it a polar or non-polar? Is it a polar, non-polar? Type in P or NP in the comment box. It's completely reverse to that of the normal reverse phase, and this is called as the polar or hydrophilic interaction. What is the mode of interaction? This is called as the hydrophilic interaction. or polar-polar interaction. That's how the retention takes place in the normal phase liquid chromatography. So addition of alkyl carbon decreases the retention. Yes or no? Why? Why it decreases the retention? Why addition of alkyl carbon decreases the retention? Why? Why? Please let me know in the comment box. Give the one statement answer in the comment box. Why the retention gets decreased in the with the increase of alkyl carbon group? Why so? It is non-polar. Awesome. Thiru, your first one to report. Vijay says like attracts like. John Stock's hydrophobic group. Awesome. All are correct. And that's so good to understand that people are able to grab the information so quickly. Let us now understand the retention behavior for these three compounds. Ready? Yes, type in R for ready in the comment box. And these are the three compounds. So which compound is polar amongst all of these three? Highly polar. Highly polar is 1, 2, 3. Highly polar compound. 1, 2, 3. Yes. Why not 3? Why not 3? Why not 3? Why everyone says 1? Because compound number 3 has got what? It has got alkyl group. Awesome. Alkyl chain, and alkyl chain is non-polar moiety, and because of that it is going to become slightly non-polar. Now, having said that the compound 1 is polar in the nature, what is going to have the retention time of the compound number 1? Is it longer retention time or the poor retention time? L for long, P for poor. Everyone come on. What is going to be the retention time for compound 1? L for longer, P for poor. Quickly. Awesome. Thank you. And which compound is going to have the least possible retention time? Between 2 and 3, we have two choices now, compound number 2, compound number 3. Which one is going to have the least possible retention time? Why compound 3, Yashwant? Yeah, because compound number 3 has got the alkyl chain longer than the compound number 2. Compound number 2 has got methyl chain, but compound number 3 has got ethyl chain. Awesome. Thank you so much. Lovely, guys. Yes, awesome. Thank you for your response. Addition of polar group like hydroxyl group is going to increase the retention time in the normal phase liquid chromatography. Why? The addition of any polar groups like hydroxyl, amine, amide, carbonyl is going to increase the retention time in the normal phase liquid chromatography. Let us take again the simple example for explaining this theory as well. So these are the three compounds onto the screen. So please let me understand which compound is going to have the longer retention time. Which compound is going to have the longer retention time? Compound 1 or 2, 3, which one? Everyone type. Vijay says 1, Neeraj says 1, Jonathan says 1, Tushar says 1. It's 1, isn't it? Because 1 is having the highly polar compound. You know, there is no alkyl chain. There is the hydroxyl group present. And which compound is going to have the very poor retention time, very short retention time? 2 or 3, which one? Thank you so much. It's compound number 2, not 3. It's compound number 2. Why compound number 2? Because this is the compound which is the most non-polar compound, or this is the least polar compound. Understand this point? Like type in U for understand in the comment box. Everyone clear? Yeah, type in CC for crystal clear in the comment box, or U for understand in the comment box. See, so quickly we could able to learn about very two important concepts of an HPLC, that is RPLC and non-polar liquid normal phase liquid chromatography.